So at first I select a new family. Furniture, let's just choose. Then I draw the top surface of the table, very basic. This is for now repeated for you, you've seen them. But then we will go through more details. The width and the length are made parametric. Now if you agree for not taking it too long, we skip these. Finish. Let's go to the elevation. Now I want to make the height parametric. Do you remember I said that we should not connect the dimensions to the objects directly, so I need to draw an RP and I say this is the height, for example. This is the height of the table. Nothing is connected to it yet, so H. All of them are in type, remember. Now I stick this to this RP and I lock it. But you surely know that the thickness should be controlled, unless when you increase the height, this happens. So I pick a reference plane as the representative of the lower part. I stick it, lock it, and now if I want this part to be parametric, all I've got to do is to measure the distance and give it a parameter. Also, I said that for not doing too much, it has a dimension, just lock it. The height, for example, 90. Now, I want to decorate around it, right? So the first thing we do is sweep, pick path. Pick path advantage is that there's no need to make it parametric, right? Anytime the size changes, the path is updated with it. So I go to this elevation. Now, for example, I want the top part of it to be a tool. So I go to edit profile. Let me make this fillet. Again, another fillet. I want the edge of the table to be curved. Now this is my shape. Alright, finish, finish. Let's check it out. This is it. I turn it into void. We could have already started drawing with void, but you could also do this. I check if it's parametric or not. 1000, for example. L, for example, 1200. So I selected a form for it, and now it's parametric. Now, let's just imagine I want to design the legs with blend. For example, 6 sides. Edit type. Let me draw this. This one, for example, 60. Let me delete this and finish. Now, this is very good. So if I drag this and stick it to this reference plane, everything will be alright. But while making this parametric, will it attend? If I, for example, change this to 1500, what will happen? Right, so we need to make this parametric. Now, because it's made of two planes, it's difficult to make it parametric. It's not impossible. So if I, for example, lock this zone, now when I change the dimensions, for example, 1200, let's see what happens. You see, it's possible to fix it, but I want to give you a professional method, which goes without any troubles. It's professional and it's called nested family. I mean that actually you need to design the leg in another file in another family and then load it into here. And because it's coming here as an object, it will not go wrong. Let's go and find out. Now I've got this family 20. Let me save it as table, file, new family, and I open a generic model. The same thing that I did there, I do here. For example, blend. For example, 35. Then edit type. And 5. Finish. But the height, what about that? Now, what you've got to do here is to make the height parametric, and when it goes to the other family, you can change the height. Now, just like usual, you draw a reference plane, lock the leg to the reference plane, and give it a parameter. We call it, for example, H leg. Now I save it as leg. So simple. So what I did was designing it first, and then the only thing I did was to give a parameter to the height, because when it goes to that table, the height should be changeable. It should be able to change. Then I'll load it into table. I'll place it here. Well, now, what's the benefit? What's the advantage? It's that you can, see, make this parametric in this zone. And if you want, you can also draw a reference plane. I'll lock these. Now check this out. Very simple, really, very, very simple. Very professional. Now, just like I said, it is called nested family. Let me write it down for you. Nested family, which means, you know, the families that are into each other. But it's okay plan-wise, isn't it? But in elevations, what about the height? What should we do with that? There's a point. Now, the height should be equal to the distance of this reference plane to this reference plane. What? Now, when you select this and then go to the type, you see this H. Now, this H is not stable. It equals the distance between these two. But we don't have a name for this distance. We cannot do that. We cannot call it anything because it cannot be parametric. Because if we measure this distance too, and for example, we wanted it to be H full leg, it will not accept it. Why? It's right, because it doesn't make sense to be both of these. When you determine this is H, this is also created automatically. You cannot name two distances that are the same. So we need a distance to have a name, but we cannot give it parameters. But you can tell me this distance is the same as what? That's right, it's the same as H minus 7 centimeters. So how can we call this distance without naming it? and giving it parameters. Now, learn this, it's so useful. At first you go to family types. Check this out. New parameters. I want to call it H for leg in type. Okay. Now, it's not connected to anywhere, is it? It's not connected to any dimensions, but I can give it a formula. You can guess the formula. H for leg equals, what? Do you remember? H minus 70 millimeters. See that? So, not directly, I gave it a name. I called it something and I clicked OK. Now, when you change H, for example, to 1200, obviously that one will change too. Now, what should I do? I need to change the height of the leg. In the edit type, I connect it through this, and well, this equals the parameters, the parameter in this file, right? I select it and I say, for example, you should always equal this, right? This is the technique. It's not used any other places, it's just here. Now, when you change H, for example, to 1200, H also changes H for leg, and H for leg was given to that height of the leg. You see the height of the leg changes. So you see, when you go to edit type of the leg, the height, which is in its own file, I mean here, it used to be, actually it was in a file we designed it in. We made the height parametric and entered here, imported it here. In this table, we named the distance. I said that it equals H for leg, and then I selected the leg and went to edit type, and using this tool we connected H to that parameter. It's one of the most professional techniques in nested families. Now I can easily pick this up, copy it, put it in different places, and make it parametric too. Well, I don't, I just measure it and lock it, because I just want the distance to be constant. Actually, these are the foundations of making the families parametric. One of them was, as a basic example, one of them was nested family. In next examples, we will use it again and I will review. You can also make these constant, stable. And of course you need to lock it. Well, as long as you haven't completely and fully understood this example, don't go for next one, because it's going to review this and you will be confused. So at first practice this, watch it again if you want, get help from us. When you are fully aware of it, go for next. Now let's try all the parameters. For example, H 80 centimeters. We never change this, we never touch it. What we change is other things, and this will change with them. This one, for example, 1500, 3 meters. One of the legs is acting wrongly. Let's see why it is. When I say test it, it's because of this. And lock. Again, change it. For example, 1 meter. Well, that one leg, again, needs to be placed and become parametric. These things are absolutely normal while making parametric. Sometimes we cannot even understand why, understand the reason. I don't say it doesn't have any reasons, we just don't find it. Just do it again, all over again. You'll probably be able to make it alright. Let me test it. From this side, it seems to be alright. Let me change them again. Now, for example, we've connected it to a place that was not okay, to the edge, for example. So don't be disappointed, just keep testing. Even if we design these, sometimes we see some errors, we just try to solve them. So far I've taught you one point, and that was nested family and the relation among parameters.